We look at the reaction of a carbonyl carbon with the addition of pregnant reagent and addition of cyanide. So today we look at the addition of, that is the reaction with water and alcohol, which is part C of the video. So reaction of water and alcohol with a carbonyl carbon. So in water and alcohol, there are two lone pairs of electrons which are responsible for attacking the carbonyl carbon. For example, this is water. The two lone pair of electrons look like this one. So these are the lone pairs of electrons which will attack the carbonyl carbon. Also in alcohols, these are an alcohol, there are two lone pairs of electrons in oxygen which will be responsible for attacking the carbonyl carbon. And obviously, this is the carbonyl carbon. So we'll be using ketones and aldehydes. So ketones, when you attach two alkyl groups to a carbonyl carbon, you form a ketone. This is the carbonyl carbon. You attach two, you form a ketone. You have aldehyde. Aldehyde is when you add one alkyl group and hydrogen to the same carbonyl carbon. So let's look at the reaction. So first we start with water. The reaction of water with a carbonyl carbon, and using an example of a ketone. So you have your ketone here. Then you have your water. This water contains lone pairs of electrons which will attack the carbonyl carbon. This one has a nucleophilic attack. So the two electrons in water will attack this carbonyl carbon. When carbonyl carbon is attacked, it's open one of the bond with oxygen. So one of the bond will open up, and electrons which was used for bonding will return back to oxygen. This process is reversible. So this bond open up, and the resulting will rearrange itself like this one. So this bond, this oxygen, we have now enough electrons. The electrons was used for bonding, be shown like that. Then this water, the two electrons now will become, this water will become insufficient of electrons, and it attach itself to this one. This carbon will attack, this carbon will bond with this oxygen using these two electrons. The two electrons which was used for breaking this carbon will become now insufficient, and obvious this oxygen is bonded to two hydrogen. The process continues. So because this oxygen have enough electrons, it will attack this hydrogen because it needs this oxygen. So when it attacks that oxygen, this bond open up and the electrons will move to oxygen, and the process continues. So when this process occurs, the electrons which was of this oxygen attack this hydrogen, and this bond open up and electrons return to oxygen. It will look like this one. Now this oxygen will combine with this hydrogen, and this oxygen, because now it will be having more electrons, will combine with that oxygen, and the resulting is a dihole. Or this is the resulting product when you add water to an alcohol, when you add water to a ketone or an aldehyde. The resulting is a dihole. Let's look at an aldehyde. The same process. So aldehyde, this one was ketone. So in aldehyde, you add again water, with lone pairs of electron. So these two electrons will attack this carbon. This bond opens up and electrons return to oxygen. You will have like this one. This oxygen will be having more electrons, and then the carbon will attach to this oxygen, which has hydrogen and hydrogen. This oxygen will be in addition of electrons. These enough electrons will attack this hydrogen, and the bond will open up and electrons goes to oxygen. The resulting also will be a dihole. The reaction is the reaction with alcohol. So we look at both ketones and aldehydes when react with alcohol. So these are ketone. Then you react with an alcohol with some enough electrons here. These enough electrons will attack this carbon, because we had said that this carbon is prone to nucleophilic addition. So as this carbon is attacked, it opens up one of the bonds with oxygen and it. So this bond will open up and electrons will go back to oxygen, and the process continues. The process is reversible, so and it rearranges itself like this one. This oxygen will be having more electrons, and this one now it will attach itself, this carbon, to this oxygen. This oxygen is attached to this alkyl group and that hydrogen. This oxygen will be having inefficient electrons. So this oxygen will be like a nucleophile, and it will attack this hydrogen. And this bond will open up and electrons return to this oxygen. And now this oxygen will be having more electrons. And it will look like this one. Because this one will be having more electrons, it will be now sufficient with electrons, and those electrons will be used for bonding with and that alkyl group. This oxygen will combine with hydrogen, and the resulting is an ketone. In the next video, we look at the formation of ketones and acetals. So this is the result. This is an ketone. Now we see when it's a ketone. Now let's look at when an aldehyde reacts with an alcohol. the same process. So these electrons will again attack this carbon. One of the bond with oxygen will open up and electrons goes to oxygen. The process continues and it's the same process, so it will rearrange itself like this one. This with this oxygen, which is combined with hydrogen and an alkyl group, and this oxygen is insufficiency of electron because the 2 electron was used for attacking, and this oxygen will be having enough electrons. These electrons that are enough in this oxygen was the electrons start to turn back when this bond open. So now this oxygen, the enough electrons in oxygen will attack this hydrogen that way, and this bond will open up and electrons will go back to this oxygen. This oxygen will be having more electrons, and the resulting product will be looking like this one. And this oxygen will combine with oxygen. The resulting is an acetone. So again, in our next video, we will look at the formation of ketones and acetones, and also ketones and acetones. So now, the reaction of water and alcohols, when you add water to an aldehyde or a ketone, the resulting is an alcohol, which is a diholds. So now let's summarize this one. So addition of water to a ketone or aldehyde the resulting product is an alcohol. In bracket, a dihole. The alcohol resulting has 2 functional group of alcohol, which is OH. That's why dihole, an alcohol which has 2 functional groups. But addition of alcohol now to a ketone or aldehyde, the resulting product is ketol and acetol respectively. As we have looked at in this process, this was an ketone, you had an alcohol, the process looked like this one, then you form an ketone, and we have said that this next video will be looking at formation of ketones. Now then you had an aldehyde, this one was an aldehyde, you had an alcohol, you form an acetol. Yeah, and that's all about the reaction of water and alcohols. Next video we look at the formation of acetols and ketones, acetols and ketones. Okay, and remember to subscribe. Please subscribe to this channel, like and comment, so that we may improve on how we'll be producing our videos. Otherwise, thank you for your time, thank you for watching. We appreciate